Alright, I'm sure you remember factoring from Algebra 1, but it has been a while, so maybe we'll refresh. It's important to know how to factor while working with polynomials, so let's review. Firstly, factoring is a process that is the opposite of multiplying, so we should really know what multiplying means. And the result of a multiplication problem is called the product. Okay, if you multiply two numbers, their result is a product. If you add two numbers, their result is called a sum. When you subtract, the result is called the difference. Alright, so when multiplying, you multiply several numbers, and those numbers are called the factors, and the factors result in a product. So for example, 3 times 5 equals 15. These numbers are called factors, whereas their result is called the product. Factoring is this process of dividing a product into its factors. Let's take a look at an example. For example, let's say we wanted to factor the number 80. You can factor 80 in many ways. One way would be to say it becomes 2 times 40. Alright, so I divided 80 by some factor of it to find out what its other factor was. So 2 times 40. Another number that goes into 80 would be 4. So 4 times 20. We can also say 8 times 10, 5 times 16. These are all factors of it. Matter of fact, even 1 times 80 would be a factored form of 80. We have negative 1 times negative 80. We have negative 2 times negative 40, and so on. We can go on for many, many other factors. Factoring a number is not so difficult. A number has many ways you could factor it generally. At the very least 2. For example, a prime number, like 7, can only be factored in 2 ways. It's either 1 times 7 or negative 1 times negative 7. Alright? So factoring a number is easy. It's just setting it up into the two things that multiplied to be it. And there is no wrong or right answer. If you're asked to factor 80 or 7, you just pick some combination that works. So let's take a look at something else. Alright, so if we were asked to factor this, let's say 6x to the third minus 12x to the second, we can factor that into its factors as well. If this is a product, we multiply two things to get it. One of them usually goes outside of the parentheses, and one of them usually goes inside. So if we were asked to factor this, one version of the factors might look like this. We could say 2 goes into both of these. Alright, so what would I have multiplied 2 by to get this? 3x to the third minus 6x squared. So this is one factored form of 6x to the third minus 12x squared. Another one would be to factor out 3 instead, and that would leave us with 2x to the third minus 4x squared. Another factored form would be to factor out 6, and that would leave us here with x to the third minus 2x squared. There are more. We can factor out x from here, or x squared even. We factor out x squared, this will be left with 6x minus 12, just 12. There'd be no x's left. Alright, so what I'm doing is I'm picking a number or a variable or a combination of them, we can even do that, and seeing what I would multiply it by to get back to what I started with. Because these two things have to multiply to be this, otherwise it wouldn't be factored correctly. So that would be 2. Alright, now one of these is more important than the other. All of these are correct factorizations, of 6x to the third minus 12x squared, but this one is more important. This one has been factored completely. And the reason for that is 6x to the third, 6x squared, undo that, 6x squared is actually known as the GCF of 6x to the third minus 12x. That's because it's the greatest common factor of all terms in the product. It's the largest number I can divide out of 6x to the third and 12x to the second with as many variables in common as possible. Alright? So I could have just taken out 6x, but then I still would have been able to factor out more. Now if that's confusing, I'll show you what I mean. Alright, so almost got it all. Let's say we had, I don't know, I'm going to make something big and complicated. Having so much trouble today with this. Here we go. Alright, so let's say we had 30x to the fifth y to the second minus 16x to the... 16 is not a good number here. I want to use a number that has a lot of factors with 30. So 45 x to the third y to the fourth plus, I don't know, 90 x to the second y to the seventh. If I wanted to factor this completely, I want to factor out its GCF. So what's the largest number that divides into 30, 45, and 90? The largest number that goes into all of them, I believe, is 15. Because 30 is divisible by 15, 45 is, and 90 is. Alright. I also want to divide them by as many of their common variables as possible. Now, some people think it would be x to the fifth, but I can't take 5 x's out of here or out of here. I can take 3 x's out at most. Actually, I can't even take 3 x's out, because this only has 2. So the most x's I could divide out of this without leaving a remainder, if you remember from long division, would be 2. I could take out 2 at most. And y's, I can take out 2 at most also. I can't take out 4, because this doesn't have enough. I can't take out 7, because neither of these have enough y's. So I'll take out those 2 y's, and we'll see what's left inside of the parentheses. 30x to the fifth, y to the second is what I'm trying to get here, so I'd have to multiply this by 2 to get the 30, x to the third to get the x to the fifth, and no y's to get y to the second. Minus 15 times 45 would be 3. 15 times... I need to get 3 x's here, so I need 1 more x. I need to get y squared, so I need 2 more... y to the fourth, so I need 2 more y's. And to get 90x squared y to the seventh, I'll need to multiply 15 by 6. To get the x squared, I don't need any x's here. To get the y squared, I need 5 y's. So this would be a correct, complete factorization using the GCF. Now, you can test that you factored correctly by multiplying. Factoring can always be checked by multiplying. So if we distribute, we should get what we started with. Otherwise, we do this incorrectly. 15 times 2 is 30. X squared times x to the third is x to the fifth. Y squared times no y's is y squared. So far, so good. 15 times negative 3 is negative 45. X squared times x is x to the third. Y squared times y squared is y to the fourth. So far, so good. Make that a little more clear. 15 times 6 is 90. X squared times no x's is x squared. Y squared times y to the fifth is y to the seventh. So we get back what we started with. So this was a correct factorization. Alright, so I'm going to erase this example, and we're going to look at what happens if you accidentally don't use the GCF. So let's say we had a problem to factor. We were given 9x to the third, y to the second, minus 12x to the fourth, y to the third. And let's say we noticed, maybe this isn't a great example. Let's change this 9 to 24. 24. The largest number that goes into 24 and 12 is 12. But let's say, for example, we accidentally only noticed that they were both divisible by 2. And we didn't take out the variables either. We get 2 times 12x to the third, y to the second, minus 6x to the fourth, y to the third. And I can distribute and check that this works. But now let's say I notice, oh, these still are divisible by 2, so I can do that again. So that would just knowing that I can do it again tells us that this was not the GCF. So I can divide out of 2 again and be left with this. I can again distribute to see that I should have gotten this, and if you notice 2 times 2 is 4. That wasn't supposed to be in black, it's supposed to be in blue. That's 4. So if I had just accidentally done 4 to begin with, I would have gotten this. Now I can factor out the 3. Both of these are divisible by 3. So I would have now 4 times 3. And that would leave us with 2x to the third, y to the second, minus x to the fourth, y to the third. Not that I recommend doing it this way at all. You should definitely do this the fastest way you can. That would be 12x. Oh, that would be 12. These two things together would be 12. So now I notice, oh, I could take out all these x's and y's. So then I would have 12, and I could take out at most 3 x's, at most 2 y's. And that would leave us with 2 minus x, y. So this would be a correctly factored completely version of 24x to the third, y to the second, minus 12x to the fourth, y to the third. So skipping all this extra steps if you don't notice what the GCF is. The GCF is easy to identify because it will be the largest number that can be divided out of both, which is 12, with the smallest amount of each variable. The smallest of the x's is 3. The smallest of the y's is 2. Now the reason we use the smallest variable is we can't take more than they have. We use the largest number because it's sort of like taking... It's the smallest amount that goes in evenly to all of them. It's the smallest of that largest number. So that's again just 2, and that would be x, y. So that's the GCF. It's the most complicated but first form of factoring you generally learn. So let's look at one more example. Uh-oh. Let's look at one more example. Let's say we had 3x to the fourth, not even, 3x squared minus 6x plus 3. The largest number you can divide out of all of these is 3. Now you can't actually take out any x's, and that's because this doesn't have any. This is really like x to the 0, meaning you can't take out any x's. And because it's like that, all we would have left here is x squared minus 2x plus 1. Okay? I hope this was helpful. Again, ask me in class if you have any questions.